Hey there, welcome back to CMTEQ channel. Do you know that it's actually very easy to set up a UART communication between two Arduinos? So that's precisely what we're going to demonstrate in this quick tutorial. So as you can see, I've got two Arduino Unos and two add-on boards. And I've got an LED board here that will be used as an output. And I've got a potentiometer here that will be used as an input. So what we're going to achieve here is very simple. Arduino A is going to have a potentiometer connected to it. It's going to do some analog reading and it's going to grab the data and send it over the UART communication. Then Arduino B is going to receive the data and control the LED on its out. It's a very simple configuration, simple software. We just need to do the setup now. So first thing, we grab our Arduino A with the add-on board. We're going to hook them together, ensuring that all the pins are aligning. Now, this is a very interesting add-on board. Let me know in the comment section if you are interested. I can provide the Gerbers for this board. Then the second thing, we're going to hook up Arduino B, ensuring that all the pins are aligning. Okay, now I'm going to power Arduino A for now via the USB to get a 5 volt. There we go. Arduino A is now on. Then the second thing we need to do here is to power Arduino B by getting power from Arduino A. So I've got two wires here that I'm going to use for my 5 volt supply to Arduino B. We can see that we've got our 5 volt and ground right here. So I'm going to plug it just like that. Then over here, I'm going to do exactly the same thing. There we go. Now we've got both computers are now running, Arduino A and Arduino B. Now, the potentiometer is going to be connected to Arduino A, as we already say. So let's go ahead and plug it onto this pin header. So I'm going to grab my potentiometer wires and I'm going to connect it right here like that. There we go. Now, the next thing we need to do is to connect the LED, the output, the indicators, and that's going to go to Arduino B. But first, I need to get a 5 volt here. So I'm going to do a quick measurement here just to see where my 5 volt is on this board. So let's test on this pin header. Oops. There we go. It's 4.7 volt. So I know that's a ground, that's a 5 volt. So I'm going to take the two pins here for the power supply for my LED board. And I'm going to plug it just like that. There we go. Now, to verify that the LED board is receiving 5 volt, I'm going to take this signal wire and I'm going to find a 5 volt somewhere here on this board. There we go. As you can see, there is a 5 volt there. LED board is powered. All we need now is a signal to control the LED, and that signal will come from the terminal of Arduino B, which will then receive instruction via the UART communication. One more thing that's left to do here is the UART link. So let's go ahead and connect the RX and TX. So that will be these two pins here. Okay, right there on my add-on board. And over here, we also going to connect the same. Now we have to ensure that we're actually connecting them correctly, but we're going to verify that after. If the program is not working, then we're going to start doing debugging. Now, these two wires will be for external power supply. Obviously, the 5 volt from the USB might not be enough, so I might require an external power supply to ensure that things are running very smoothly. So the next thing to do here is to basically start writing the code for Arduino A and the code for Arduino B. Now let's open the code for this Arduino. Great stuff. Now here we've got Arduino A script. As you can see, we just initialize the LCD. We basically just print as a sender. Obviously, we're doing a serial print to send the mapping values over the UART communication, and we're doing a basic printing on the LCD. So that's the code for Arduino A. So I'm going to go ahead and right away start writing it in. Okay, uploading. Oops, it is not uploading. I know what is the problem, so I'm going to cancel it. I'm going to disconnect the UART pins here, and I'm going to start again. Uploading. Is it uploading? There we go. It's uploading, and the value says 0 from the sender. Let's give it a test. There we go. As you can see, we are already changing the potentiometer value here. It's going from 0 to 255 as per our mapping there. Now, the only thing we now need to do is the code on Arduino B. So, Arduino B here, same thing with initializing the LCD. So, we need to connect it on pin 9. That is the control pin for the LED. And inside our main loop, we basically do a checking of whether we've got some data available on the serial pipeline. So if we have data on the serial pipeline, then we can start doing stuff with that data. So the things that we're going to do is to basically just get the data and do analog write. Okay, and then we display the data that we are basically getting. Very simple. So let me now disconnect the USB. Okay, so if I disconnect the USB, this Arduino is going to go off. That's fine. Let's do that. And we're going to place it now on Arduino B. There we go. Now moving the USB from Arduino A to Arduino B gave me some COM port problem. After fixing that, now we can now go ahead and flash the Arduino B code into Arduino B. Is it uploading? Looks like it is uploading. It's done uploading. And as you can see, we've got a sender here and we have a receiver. Now, before I start running, let's bring the external power supply here. And I'm going to set it to 10 volt or 9 volt because I'm feeding it into the Arduino onboard voltage regulator, so I can feed in a 9 volt. So let's go ahead and connect our 9 volt. There we go. Now you can see that the signal from the LCD is very solid because it's no longer a weak 5 volt. Okay, now we know that from the Arduino B perspective here, the LED must be on pin 9. Now let's open the mapping again, and pin 9 is basically that second pin here. That's pin 9. So I'm going to go ahead and connect it right there. Okay. Great stuff. Now the only thing that's missing here to complete our demonstration is the UART communication. Everything on the Arduino A is working. I can control the analog input with my port here, but there is no reaction on Arduino B side. The LEDs are still off. So let's bring the UART communication here. There we go. As soon as we connect our communication link, 241 is now also available on Arduino B. Oops, what just happened there? Probably the 5 volt here is not very solid. I mean, the connection is not very solid. Okay, now as soon as I start controlling the potentiometer, you can see we're getting a change on both Arduino. But the control is happening on Arduino A, and on the receiver, we're also seeing the light is actually dimming, as you can see, as the analog write value is decreasing, and we go the light completely shut off, and we start increasing, and the light is getting brighter and brighter. So this is basically how you can demonstrate a UART communication between two Arduino. And obviously, if I remove this, and that's going to switch off, because what's keeping it on is the data coming from Arduino B. So now, what kind of application can you do with this setup? All sort of application. Thus, Arduino A could be a remote server sitting somewhere that can be sending instruction to another server somewhere. This server can be basically controlled by Arduinos, and you can have your communication link and data being set by either one of them. So that's basically how you can do it. And this can actually be a bi-directional communication, because you can set Arduino B to also talk back to Arduino A, and Arduino A must also process the data coming from Arduino B using the same communication link. But you have now to enable a bi-directional communications in your software. So that is it, guys, for this quick demonstration. If you found it useful, please make sure you give it a thumbs up and subscribe to CMTEQ channel. That will be highly appreciated. Until next time, cheers.